Hi, hi, I'm Yusuf Abdullahi, and I work as a tutor for statistic assignment experts. I want to share with you in this video um, a solution to an assignment based on ANOVA test using Microsoft Excel. In my two previous videos, I have demonstrated to you how to use Excel to solve paired sample t-tests, independent t-tests, and equality of variance. So in this, I want to answer the third question, that is BMI significantly different across race. So we are saying that race 1 equals to race 2 equals to race 4, and my alternative hypothesis would be race 1 is not equals to race 2 not equals to not equals to up to raise 4. So we are saying that our null hypothesis that the BMI is the same across race, and our alternative is that at least one of the categories of race is significantly different. So let me show you my data set. So this is my data set. Let me clear all this. Let me clear everything. So in Excel, to carry out one-way ANOVA test, you go to data, then you go to data analysis. So you go to one-way ANOVA. So you see ANOVA single factor. So ANOVA single factor. You click on OK. So you can see that we should input range, and the range we have is just only one box. Yes, it's just only one box. And what does this mean? There is no place for our independent variable, which is race. So it means that, like I explained in independent test, so we have to partition this variable, the BMI, into 4, which is the categories of race. So how do we do this? So let's say we say race 1, race 2, race 3, and race 4. So we have to partition our data. So how do we do? So we use the same solution we use in independent test. So we highlight everything. When we highlight, we go under data, we sort. Now we are sorting by race. So we sort by race, then we click OK. So we can see now that the race equals to 1 is together, then followed by 2, followed by 3, then followed by 4. So we will now copy BMI poles for each of these categories. So yeah, so I will copy these, and then I will paste it. Then I proceed to choose. So I will start from here and then copy to where 2 ends. So I can see that 2 ends here. So I copy to that place. Then I will paste here. Then I go to 3. Go to 3. I will post here. Then finally I will go to 4. So sorry, I'm not going to copy for, I'm going to copy BMI for 4. So I will copy this. So I copy here. Then my data is ready. So I go to data analysis, ANOVA single factor. Then on my input range, I click on this. So I click on this. Then group by, since my data is arranged by columns, then label in the first row I will highlight it because my first row is variable name, and then I'm using 5% alpha. So if I need my result to be displayed in this workplace, so on this worksheet I click somewhere, then I press OK. So I can see these are my results. These are the results. So I can see these are race 1 has 137 observations. This is the average, this is the variance. Race 2 has 84. This is the average, this is the variance. Race 3 has 53 average variance, and race 4 has 26 observations, and this is the average, this is the variance. So these are the ANOVA results. So I have between groups and within groups. So this is the sum of square. So we have sum of square between groups and sum of square within groups. So we can call this one error, and sum of square between groups. So this is my degree of freedom. The degree of freedom for here is the number of groups 1, 2, 3, 4 minus 1. So which is 4 minus 1, that's 3. And my within group, so the total here is n minus 1, that is 300 observation on the whole minus 1, that's 299, and then 299 minus 3 give me 296. So this one is n minus k, that is 300 minus k minus 4, that's 2. So my mean square error is these are divided by these, and then for within group this divided by this. Then my L statistic will now be the division. It will be this over this. So you can see now. So that's my L, and then the p-value, that's the p-value, and then the critical value is the tabulated value. So if we see this result, we can see that our F statistic is less than the critical value, and the p-value is greater than 0.05, which means we cannot reject the null hypothesis that BMI is the same across race. So it means that the post BMI is not different across race, and the categories of race they have the same BMI. So for any assistant on statistic assignment, email to support@statisticassignmentexperts.com. Thank you.